Natural logarithms. A natural logarithm is a logarithm with base e. We write ln of a to represent log base b of a. Note that e is equivalent to 2.718281828459045 dot 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 dot. So it's a continuous number basically, 32 plus digit number. Think about it sort of like pi. Pi represents 3.14 is our estimate, but in reality, let's visualize our calculator. There, good visualization on your calculator. So if you turn it on, push the second, and then push the clear button, well, not the clear button, the button right below, which is the caret key, should have a pi on there built in. So there's a little bit more of a lengthy number, 3.141592, etc. So it's already built into your calculator. Likewise, E is already built into your calculator. Notice that it's the ln button. If you push the ln button, it gives you ln. But if you push second ln, once again, ln button is right below the log button or right next to your number 4 keypad. Second ln will give you e. If you put a 1 on it, it'll give you the e value, which is exactly what we have there at the left. 2.71828, etc. It's a continuous number once again. Let me just clear it out. So we don't want to write that number a lot of times, right? Especially when you're doing work or homework. So in that case, that implies that we want to have a shorthand way to write it, which is to say ln or e instead. So like pi, it's a shorthand way of writing 3.14, etc., right? It's a continuous number. We don't want to write it more than once, essentially. So let's, for instance, here we have log base 10 of 100. We know 10 times 10 gives us 100, right? Or you can try this in your calculator. Push the log button, it's base 10, so you don't have to push anything else, right? Other than putting 100 in. Close your parentheses, hit enter, it tells you that you multiply it twice. 10 times 10 gives you 100. You multiply 10 twice. Or likewise, we can convert it, agreed? Log base 10, once again, we don't have to show it, but you can show it. But if you convert it 10 to the second power, well, log base 10 of 10, they're equal and opposite. We've seen this previous videos, right? They cancel each other out. So log base 10 of 10 cancel each other out, leaving us with the exponent, or we can say the log allows us to bring down an exponent, so it becomes a 2 times 1, which is what we have as our final answer, 2. So ln and e, similar concept, they're equal and opposite. So notice you don't have to write them down, it's already there. ln has the e function, so it's log base e. So ln and e to the fourth, for instance, they're equal and opposite. They'll cancel each other out, leaving you with just a 4. Or you can bring down the 4 and say 4 times 1 equals 4. Or just say they cancel out and they leave you 4 because of the exponent. Short way of thinking this. But once again, long way of thinking about this, it's just a log with a base e. And it's raised to the 4th power. So log base e of e, they both are equal and opposite. They cancel each other out, leaving you with the exponent of 4. Or you can say you're bringing it down to 4 times 1, agreed? Which is still 4 no matter what. So there it is. There's another way to see this. Now let's take a look at some basic calculations. So we have exponential slash neutral or natural logarithmic form properties. So for a greater than 0, the equations ln of a equals c and e to the c equals a are equivalent. We've seen this sort of equations, agreed? We used to use them for logs. So we used to say log base b of a equals k, which we would say also b to the c equals a. Remember, that's a k. You can use it as a k or a c, agreed? It's whatever variable you choose to have in this case. So I'll recommend you either write it as a c or as a k. But choose one or the other, but not both like I have here. Be aware of that. I'll fix it in a minute. So ln of a equals k, and then keep in mind we're converting that. Once again, e to the c equals a are equivalent. So this is the basic function with natural logs. They're equal. They're the same thing as saying log base e, or e to the c equals a. Alright, let's try the first problem then. ln of 20 equals 2.9957. That's just basically a calculator check. So on your calculator, clear anything you have, push the ln button, once again right next to your number 4 keypad, or right below your log button, push the ln, put a 20, close your parentheses, and hit enter. You'll notice that you get 2.995732, etc. It's a continuous number. So this is a rough approximation. So there it is, our rough approximation. Let's go for the next one. That was fairly easy, right? Calculator work. ln of e to the power of 8. Once again, note, ln is the same base as e, right? So they're equal and opposite. Quick way to think about it, they cancel out, we're done. We get an 8. Pretty straightforward, right? Long way to think about this is it's log base e of e to the power of 8. So they're equal and opposite, they cancel out and give you an 8. So technically both ways you get a cancellation to give you an 8. Or 8 times 1 equals 8, right? So be aware of that. So remember, ln and e cancel each other out. Bottom line. Number 3, ln of t equals 6. So ln of t equals 6. Let's try converting this. If we convert it, remember, ln is base e, so it's e to the power of 6, right? So that's what's on the other side of the equal sign. It's our a value, essentially. Well, not a value, the c value, the exponent, or the k, depending on which one you chose. So e to the 6 equals t, and now this becomes a calculator work, right? If you push second, ln will give you the e function, e to the 6, close your parentheses, hit enter, and it gives you that the t value is 403.4 roughly. So once again, 403.43, rounding a little bit more. One extra decimal. And now let's go for the next one. Number 4, we have 3 ln of 2x minus 4 equals 8. We gotta realize there's a subtraction and a multiplication. We gotta get rid of those before we can go to the next step, right? Conversion. So let's get rid of the 4 first. So minus 4 plus 4 from both sides then. Minus 4 plus 4 will cancel out, leaving us with just 3 ln of 2x equals 12. And now let's get rid of the 3. It's multiplying, opposite, divide. So we're going to divide by 3 on both sides. 3 divided by 3 cancels out. That leaves us with ln of 2x equals 12 divided by 3, which is 4. And now we can convert. So ln of 2x equals 4, and the conversion e to the power of 4, right, because that's on the other side of the equal sign originally, equals what's in the parentheses, 2x. So e to the 4 equals 2x. And now let's get rid of the 2 via division. But likewise, we could get a number right now for e to the 4. But we'll do it in a minute. So divided by 2, 2's cancel out. Now we can do it. So now let's try it out. Let's see, let's clear out our calculator. We have second button. ln gives us the e. We want to put a 4 for the exponent, close your parentheses, and then divide by 2 as our last step. There we go, and that should give us our final value of 27.299, or 27.3 roughly, depending on how you prefer to round. Again, your choice. So 27.3 therefore is our answer. And there we are. Once again, natural logs, not huge difference between natural logs and logs. They're very similar, other than we're calling it base e rather than any other base, like we typically did with log. Natural log is very specific to base e, which is a specific number of 2.71828, etc., right? So be aware of that. Once again, there are our final answers. And quick checkup on all of them. You can always plug in your calculator, right? Alright then, so almost skipped out on the correction. Let me not forget to correct that this instead of k should have been c. Agreed? So log base e of a equals c. And ln of a equals k should have been ln of k equals also a c. So there we go. Final correction to our notes up there. So log base e of a equals c and ln of a equals c. Technically they're the same once again.